Okay, example 2, modeling population growth. It says in a research experiment, a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 125 flies, and after 4 days, there are 350 flies. How many flies will there be after 6 days? Well, first we know, it tells us here at the beginning that it's going to be with exponential growth. And so we know that the equation we're looking at is going to be y equals a times e raised to the bx. Well, they gave me two ordered pairs here. The first ordered pair they gave me says at 2 days there are 125 flies. So I can write that as 2, 125. Then they also gave me another equation that said after 4 days there were 350 flies. So I can write that as 4 and 350. Now, we can plug, both of those are an x and a y, so we can plug those into our equation that we have up there at the top for the exponential growth. So we end up with this first one. We have y, so 125, equals a, we don't know, times e, which is a number, raised to b, we don't know, but we know x is 2. And we can do the same thing for the other ordered pair that they gave us. Our y, which is 350, equals a, we don't know, times e, which is just a number, raised to b times x, which is 4. Now, because both of these come from the same equation, to get those two ordered pairs, we can solve one of these equations for one variable and substitute it into that other equation. So let's do that now. So I'm going to change colors here. Alright, so we need to solve one of these for one variable. Where the easiest variable is going to be a, because b is up in that exponent, and we're going to have to do some log stuff probably to get rid of it. We know that. So let's pick one of the equations and solve for a. So I'm going to pick the first one there just because it's first. So I'm going to solve for a by dividing by e to the 2b. So I end up with a equals 125 over e to the 2b. Now that I know that, I can bring that over to this other equation here, and I can plug it in for a. So we get 350 equals a, which we just said it was equal to 125 over e to the 2b times e to the 4b. Well, I'm going to just simplify that a little bit in how it's written. And so when we multiply, this is like over 1, so we multiply straight across, so we get 125 e to the 4b divided by e to the 2b. And then we can simplify this right here. Remember, when we divide, what do we do with our exponents? We subtract them. So we have 350 equals 125 e to the 2b. Then we need to divide by that 125. So that cancels. I end up with e to the 2b equals 350 divided by 325 is 2.8. And then this is in exponential form, so from what we learned in like 3.2 and 3.3, we're going to write it in log form, or we could just go ahead and log both sides. But this is my a to the y equals x, so I'm going to do log base a of x equals y, and then I need to divide by that 2. So I end up getting b is equal to log base e, remember, is a natural log of 2.8, all divided by 2. And, I wrote a little big, so work that out, and we get b is approximately 0.515. Well, once you solve for b, we can take that b now and plug it back into the other equation we had over in the other part, and we can solve for a. So that's what I'm going to do next here. So I'm going to take this b value, and I'm going to come up and over, and I'm going to plug it back in right there for b. So I end up with a equals 125 divided by e to the 2 times 0.515. All right, let's put that in our calculators, and we end up with approximately 44.626. All right, so now we know A, now we know B. If all we needed was our model or our equation, we would just plug this in. So for right now, our general equation that we have found is going to be y equals 44.626 e Remember, to the bx, it'd be 0.515x. If all I wanted was a model, I would be done. But we're looking for, excuse me, we're looking for how many flies will there be after 6 days. Well, remember, days is our x, so we're going to plug in that. So x equals 6 days. So let's plug that in. So we get y equals 44.626 e to the 0.515 times 6. And we do that, and we end up with approximately 980 flies.